Morning, y'all. We're gonna go ahead and get started with today's new, moving on from law of exponents, multiplying polynomials to actual factoring. So this is something that you have definitely seen sometime in elementary, middle school. So we're just going to kind of revisit it to make sure that you kind of have the skills. So again, this is called factoring. There's a total of 3 ways that we'll learn to factor. This first way is going to be what we call factor by GCF. All right, so we're going to be factoring by GCF. So we're going to go over a couple of vocab things real quick, just answer these questions. So in multiplication, the numbers multiplied together are called, they're actually called factors. So I'm going to write factors here. And the answer to a multiplication problem is called product. So when we multiply two things together, those two things are factors, and that will give us a product. So in the problem, 5 times 4 equals 20. What are the factors and what is the product? So the 5 times 4, this right here would be our factors, which means that our equals 20 piece right there, that would be our product. And so we can say that 20 can be, and we can actually say factored into 5 and 4. Okay, so those are some basic questions to kind of get us started. We're actually going to go ahead and define greatest common factor. So greatest common factor is simply the largest number that factors into 2 or more numbers. All right, so that's what greatest common factor is. And so to find the GCF, think of our definition. We're trying to figure out what is the largest number, aka factor, that will go into both of these numbers. So I know y'all are accustomed to probably the factor tree. We're actually going to use something else. We're going to call it upside down division, aka ladder. So you'll hear it called ladder. You'll hear it called upside down division. You might hear it called UDD for upside down division. So just understand all 3 of these names mean absolutely the same thing. So to get started, we are going to go and write our 2 numbers. I'm going to write 48 and 60. And I'm going to put an upside down division sign. Some people call this the ladder. So for our first time, we're going to figure out what number goes into both. A hint that I want to give you, because some of us can't easily see what the GCF from the 2 of these. If you have 2 even numbers like 48 and 60, they end in 0, 2, 4, 6, or 8, you can always factor out a 2. So I'm going to put a 2 here. And so 48 divided by 2 will give us 24 here. And then 60 divided by 2 will give us 30. So now we can keep going. So again, they're both even, but I'm pretty sure some of you can see that the number 3 will go into both of them as well. So I'm going to go and take out a 3. So 24 divided by 3 is going to give us 8. 30 divided by 3 is going to give us 10. And then if you notice, they're both even. So again, we can pull out a 2. Some of you can probably just look at it and know that 8 can be divided by 2, and 10 can be divided by 2. And so we end up with 4, and we end up with 5. And so there's not a number that will go into 4 and 5. So we're actually done with our actual ladder. And along the outside of our answer here is our GCF. So some teachers like to make a G just to remind us that that is our GCF. And all we're going to do is multiply all those things. So 2 times 3 times 2. So 2 times 3 is 6. 6 times 2 is 12. And that simply means our GCF is 12. Cool. And that's all it is to it. So let's look at the second one. Here we're told to find the GCF of 15 and 16. So when we look at that GCF of 15 and 16, I'm going to go ahead and set up my upside down division. So I'm going to have my 15, my 16. And when I look at this, I know 2 doesn't work in 15. 3 does, but we can't. 3 doesn't go into 16. 4 doesn't work. 5 does work, but doesn't work in 16. 6, 7, 8, 9, 10, none of those work. 11, 12, 13, 14, 15. So the only number that these two have in common is 1. So my greatest common factor of that would be 1, excuse me. So anytime your GCF is 1, it's what we call it being relatively prime. So relatively prime if GCF is 1. Cool. All right, so that was just finding GCF. We're going to use this whole ladder method to actually do some factoring. So we're going to go look at this example here that we have. So in this example, we have our 36 x squared plus 54 x. And so in this example, we're just going to focus on the numbers first, like what we did up here. All right. So when I look at 36 and 54, both of those numbers are even. So I'm actually going to go ahead and take out a 2. So 36 divided by 2 is going to give me 18. And 54 divided by 2 is going to give me 27. If you notice, I left my variable, my exponent the same. I'm also going to carry this plus sign straight down. All right. So now I can look at my next layer of my ladder. So when I look at this one, again, I have 18 and 27. They're both not even, but hopefully you can see what number will go into both of them. That's right, it's 3. So we can do 18 divided by 3 is 6. I'm going to leave my x squared alone, bring down my plus. 27 divided by 3 is 9, so I put my 9. And then when we look at it again, we can see that another 3 will come out. So let me get a different color just so you can see the different layers. So I can take out 3. We're going to be left with 2x squared plus 3x. And so when we're factoring, we're always going to deal with our numbers first, and then we'll look at our variables. So when I look at the variables here, I have an x squared, and I have an x. And I'm going to put the imaginary 1 just so we can remember that it's there. So when dealing with the variables and factoring out my variables, I always want to look at the exponent. So this one has an exponent of 2, and this one has an exponent of 1. And you always want to think which one is smaller. So x to the first is smaller, so I'm going to put that on the outside. So now we're going to divide. So essentially, I'm just going to make a little side note. So over here, we're doing 2x squared divided by x. And so if you remember from what y'all did last week, that is our coefficient because there's nothing to divide it against. And then when we divide, we subtract our exponents. So 2 minus 1 will give me x. So I'm left with 2x. And I'm going to do the same thing for this. I'm going to have my 3x divided by that. So I'm going to have my 3x divided by x. 1 and 1. So we get x to the 0, which is just 1. And essentially, you could just cross that out as well, because we know that that is equivalent to 1. And so now if you notice, there's no x's that we can take evenly. Another way to think of it is we have 2 x's here. We take out 1, we're left with 1. We have 1 x here. If we take it out, we have no x's left. So a couple of ways you can look at it. So let's go ahead and write out our final answer because we're really close to the end of this one. So again, this is our GCF. Some teachers like making a little g, so I'm going to just include that. And for our GCF, we're going to multiply each part. So we're going to have our 2 times our 3, which is 6. 6 times 3 is 18. And then we have our x, so we have 18x. And that would be our GCF portion. Our leftover is this last little layer right here. We're just going to put that in parentheses. So we have 2x plus 3. So the format that we write it in is we put our GCF on the outside and we put our leftover on the inside. And so if you notice, just a couple things I want you to notice is that if we were to distribute this, we would end up with our initial question up here. So 18x times 2x gives us 36x squared. And 18x times 3 will give us 54x. Another thing I want you to note is that instead of doing 2 times 3 times 3, we could have taken out 18 from the beginning and had less steps to do. So the better you are with your multiplication, the shorter your ladder will probably end up being. But just so that you know, this is our final answer. I'm going to stop here just because I know this video went a little bit longer than what I was planning on. So I'm going to stop here and then I'm going to have a part 2 where I do a couple more examples.